Computational thinking is a set of problem-solving techniques that we use here at Google. One aspect of computational thinking is decomposition, where we take a large problem and we break it down into smaller pieces. Another aspect is pattern recognition. We use pattern recognition to help us identify similarities and differences. The final part of computational thinking is algorithmic design. That allows us to create a step-by-step strategy for solving a problem. Google Earth is a perfect example of computational thinking because it takes a large problem of trying to visualize the entire planet and makes it so that anybody can explore the world around them.
Google Earth is basically an attempt to recreate the whole world in 3D. And we want to make it as if it's the real world. We don't want to make anything up. We don't want to create anything or invent anything. We want to make it the real world. And initially it seems like this crazy problem if you really think about it. The world is huge. It takes a tremendous amount of data. If we were to try to send this to you, we'd have to pull up in front of your house with tractor trailers full of hard drives of all the images. So it seems kind of impossible, but we make it possible. In school, you're given these problems that are very black and white. You know, you either have the answer or you don't have the answer. You got it right or you got it wrong. In the real world, there are many right answers.
Google Maps is a collection of imagery and data about places and roads all around the world. And using Street View, we actually have images from cars right along all of the streets. Once we've collected all this imagery, we have to somehow put it together in a way to be able to share it with the world. Not long ago, I started getting annoyed with Pegman. Pegman is the little yellow guy on Google Maps that you can drag to get into Street View. And so you drag Pegman from the corner in Google Maps and you drop him on the street you want to get into and look at. That works great when you know exactly where you want to go, when you want to zoom all the way in on a single address and drop him next to a house or something. But say you just want to go to New York City. When I drag and drop Pegman, he'd fall somewhere, well, somewhere random. In fact, he seems to prefer to land in back alleys. He didn't mind landing in the middle of a field. He'd land on big highways, but he'd almost never land in front of a famous landmark. And if you dropped on Paris, he'd never, ever land on the Eiffel Tower. I thought to myself, we can do better than that. We kind of know what famous places are in the world. We should fix this. I began to think to myself, what makes a panorama, one of these images in Street View, important? And then I thought about it further. I thought, when people go to places that are interesting, when they physically travel there, what do they always do when they're in a famous place? They pull out their camera and start taking pictures. People post a lot of these pictures to the internet. So we could look for places that people take a lot of pictures. We can find things that are in those photographs that people took and see if we can find the same things in the Street View images. And so if we can see the Eiffel Tower in the Street View image, and we can see it in a bunch of images people took, we can automatically know that it's probably important. We've worked really hard to make Pegman smarter. When he's dropping from the sky, we want him to land somewhere interesting.
Thinking computationally is a lot more like art than it is like math class. You go in and you know you want to create something and you have a blank canvas, and you use math and you use these tools to paint on that canvas, and you end up creating something beautiful.